Today we discuss question number 23 in moment of inertia. Calculate moment of inertia of a circular disk of radius r from which a small disk of radius r by 2 is removed about axis xx dash, which is in the plane of the disk. Take mass of the disk is m after removal. This is the question. Actually, concept of negative mass we discussed in center of mass. Exactly same thing we use, right? First of all, we take the disk. This disk can be considered as combination of one complete disk plus exactly cavity sized negative mass. This is having negative mass. So when you take the negative mass disk, when you place it on the positive mass, both gets cancelled. We know moment of inertia of disk about this axis. Standard table, it is there. We'll take it from the table. And we know that this equal to this, both are equal by sense. Then we use perpendicular axis theorem and we find it. You know the procedure how to deal with it. And in this case, radius will be r by 2 because the radius is r. For the cavity, diameter is r. Radius is r by 2. And then we can calculate moment of inertia about this axis. And then we can add. First and foremost thing, crystal clear rule is there. That rule is this positive mass and negative mass should have same density. Then only it will completely cancel. If it is a little bit more dense, this one, negative mass, than this, some negative mass which is uncancelled will be there. Second point, in case of moment of inertia, the mass is very, very important. If I have a disk with cavity like this, center of mass will be somewhere here. If the disk is made up of thermocol, center of mass will be here only. Now, if I make exactly identical disk with the metal copper, assume copper, center of mass will stay there. It won't change. But moment of inertia is not like that. When mass changes, it changes. Okay? You need to be very careful. If I gave this question and asked you to solve, there will be few students who knows everything, they're perfect. But only mistake they do is that when they take areal mass density sigma m by pi r square. Pick up what is the mistake in this. It's clearly given take mass of the disk is m after removal, not before removal. So it must be pi r square minus pi r by 2 whole square. You have to write like this. This is the first and foremost thing. In case of center of mass, whatever way you do, it doesn't matter. If you take like this, the other way around, you'll get same answer because it depends on ratio of masses, not on the exact mass. Here it is not like that. So sigma is equal to 4m by 3 pi r square. This is the sigma. Okay. Now let us calculate the first one, m1. m1 is equal to mass of this complete disk, density into pi r square. If you substitute the value of density from here, then it will be 4m by 3, m2. m2 is equal to sigma into pi r square by 4. That is equal to, substitute the value of sigma from here. It will be m by 3. So masses are 4m by 3, m by 3. We got the masses. This is negative mass, remember. Then we have to go for moment of inertia. Moment of inertia of a disk about this axis, we know. We calculate moment of inertia. That is from table. I is equal to mr square by 2. Mass of the disk is 4 by 3 m r square by 2. That's a moment of inertia. But we want moment of inertia about axis passing through the plane. Then you know very well. I'll take two mutually perpendicular axes. I'll take I1 and I1. By using perpendicular axis theorem, I can say I1 plus I1 is equal to I. So that I can write this as what, tell me? 2I1. I1 is equal to what, tell me? mr square by 3. So moment of inertia of disk, complete disk about this axis will be mr square by 3. Okay. Now I need to calculate moment of inertia of this negative mass. Minus sign, I'll put it at the end. Let me calculate normally. So as I discussed already, moment of inertia of this disk about this axis will be mr square by 4, m by 3. Why m by 3? Mass is m by 3, check it. m r square. R square means r by 2 whole square here. The radius of the disk is r by 2. That's why mr square by 4. Right? We got the moment of inertia of the disk in the plane. Okay. mr square by 4. But I need to use parallaxes theorem. So if I use parallaxes theorem plus mass is m by 3 d square, distance between them is r by 2, r square by 4, r by 2 whole square, you can write anywhere. That's the moment of inertia I2. Let us call this as I2. Now I got I1 and I2. You need to simplify this. Then you will get the answer. This value will be 5m r square by 48. Now we need to calculate total moment of inertia. I is equal to I1 minus I2 because negative mass. That is equal to mr square by 3. I'll do one thing. 16 mr square by 48 I'll write. Mathematical simplicity, that's it. Then this negative mass minus 5m r square by 48. So total value will be 16 minus 5, how much? 11. 11 m r square by 48. That's the answer. Moment of inertia I. Now I'm going to teach a concept here, which is not there in any textbooks. Not perfectly it will be given. That is, do anything without changing perpendicular distance. Then moment of inertia won't change. I'm not getting it. Let us keep it aside. Let us take an example. There is a particle of mass m rotating about an axis. Mass m axis, everything is given. This is the particle. This is the axis. For the better view, if you see the top, it is good. From the top view, I'm giving it to you. Now we have a particle here. And this is the axis. I'll do one thing. I divide the particle into 5 pieces. Each piece will be m by 5. What I'll do is that I will keep them at different points, but distance on the axis remains same. Something like this. Second particle, third particle, fourth particle, fifth particle. Each particle is having mass m by 5. This is having mass m, assume. M by 5. M by 5. Now, what is the combined moment of inertia of this combination of 5 particles? Sir, this one will have moment of inertia m by 5 r square, because let us take this distance as r, this is also r. And all 5 particles at r, so into 5, that is equal to what, tell me? mr square, right or wrong? Moment of inertia remains same. So a single particle at r, or the same particle, is divided into 5 pieces at 5 different positions, but r remains same. The key idea is that without changing perpendicular distance. Okay, let us understand this one a little bit more deep and see how we can use it. Lot of ways are there. Let us take axis about this point, right? This is the axis, this is the side view, this is the top view. And I indicate axis with into like this. Okay, now observe this part. If you got this idea, you can lead to this one. Check it. There is an axis and particle r is there. Now what I'm going to do is that I'm going to stretch the particle. Stretch the particle, yes. Sir, how can we stretch the particle? This is not x, r, na? Sorry. R. How can we stretch the particle? Think about it. If you stretch the particle, stretching means mass won't increase. Stretching means mass won't increase. You are not increasing mass, just simply stretching. You are stretching in such a way that you are not changing perpendicular distance. Understood? Check it. You are not stretching along a straight line. No. You are stretching along a curve. Like this. But any part of the mass m will be perpendicular distance r. It will be. Now moment of inertia remains same, na? mr square. Now extend the same idea. See how it will be. We have a particle and distance is r. This is the distance is r. Axis is like this. Now extend the particle, complete a circle. You will get a ring. Moment of inertia of ring is mr square, right? I think you mugged it up. It's in the table. We'll extend this idea to the different dimension. Okay. We take the ring, same ring, we calculated about the axis. Side view, I'm giving it to you. Mass M, it must be R. Okay, fine, we'll continue. Now, without changing perpendicular distance, do anything, moment of inertia will not change. So what I'll do is that I'll stretch the ring along the axis. It becomes a hollow cylinder. Moment of inertia will be mr square only. See where we started, where we ended. We started at particle and we stretched as a ring, then we gone to cylinder. Last idea, I can put in words, I can give you as a statement. I'll give a statement here. For any two-dimensional object, not 3D, if you extend, or in fact, you can go for compress also. Along axis, perpendicular to the plane, moment of inertia will not change. Check it. This statement you can take and you can remember this as a statement, but core idea is not changing R. Now you have a cylinder, hollow cylinder is there. I know moment of inertia of a hollow cylinder. If I compress it like this, while compressing C, any particle you take it is not changing R. Suppose if I take particle here, by compressing particle will reach here. R is not changing. Up to now we are learning extension, learn compression also. Suppose if I have an arc like this, if I compress it, nothing will happen. Every particle is at R only. Perpendicular is same. So both ways you must be in a position to do that, is taking an object, extend or compress, both you need to do. You need to develop, okay? We can extend the same idea to what? A disk. Same diagram I can take, a disk is there. If you extend the disk, it will be a solid cylinder. Moment of inertia of solid cylinder is mr square by 2. Remember, it doesn't work for 3D objects. Right. My statement is simple. That is, I'm not telling you this statement, extend without changing perpendicular distance. This is applicable any case, anywhere. Forget about two dimension, any case, anywhere. But this statement, the second statement, is a byproduct of the previous one. It is applicable only for 2D objects. Sir, I'll do one thing. Without changing R, I redistribute the mass as a sphere. So moment of inertia of a sphere or shell will be mr square. No. Why this is not allowed? Because when you take it as a shell, observe some particles are getting closer to the axis, right? R is all about perpendicular distance. R is not radius. Perpendicular distance. It is changing. You have to be a little careful there. So while using it, you have to be a little careful. Not to do it completely random. Okay. This is the fundamental statement and this is the derived statement from that. We can extend same idea to another object. You have a square plate, you know, moment of inertia of a square plate. ma square plus b square by 12 is for rectangle. Now a is equal to b. It will be ma square by 6 for rectangular plate. Now if you extend it, it becomes a cube. So moment of inertia will be ma square by 6 only. Those who cannot handle this one, just remember this, try to handle partially. It's a subset of that one, right? I use the same idea, do it a little wild. I'll take the disk of mass m radius r. What is the moment of inertia? mr square by 2, obviously about this axis, perpendicular to axis, right? Perpendicular axis. Now I divide it into 4 parts. Just I'm going to cut it. I'm not going to do any change. Just I'm cutting it for just to show you something. What I made is that I made slight gap here, but in reality, just a cut. So no mass is removed, nothing, just cut 4 pieces. Right? Now, once I made it into 4 pieces, what I'll do is I'll take one piece, I'll rotate by 90 degrees, and I'll move it here. Before removal, this piece I'm taking, what I'm going to do is that I'm going to put a dot here, and then what I'm going to do is that I'm going to place it here. You see, what is the perpendicular distance? What is the perpendicular distance here? R. Now, when I rotate and place it here, now what is the perpendicular distance? Tell me. R only, na? This is the axis, right? Perpendicular distance is R. I'm giving you top view. Previously, we studied one particle or one object without changing R. Now, we are studying object with multiple particles, and I'm doing some modification without changing perpendicular distance of any particle. Can you understand? I repeat. I took one particle here. Okay, accepted. But like that, many particles are there. All particles has their own perpendicular distance, right? Now, when I rotate this and place it here on top of the previous one, moment of inertia remains same. I do the same thing for this also. This also I rotate, I'll place it here. Now, what is the moment of inertia of this combined disk, semicircular disk? mr square by 2 only, it won't change. Anyway, I'll rotate like this, I'll place it here. And this one also, rotate like this and place it here. What is the moment of inertia of this 1/4 of a circle?
It will remain the same, like mr square by 2.
mr square by 2. Now, this is confusing. Next part, what is that? See, student will get confused between a quarter of a circle with mass m, radius r, moment of inertia is mr square. That's fine. If they say like this, there is a complete disk. From the complete disk, if 3 parts are removed, 1, 2, 3 parts are removed, only one part is there. What is the moment of inertia? In that case, it is mr square by 2 into 1 by 4. Sir, here you haven't taken 1 by 4. Why you are taking 1 by 4 here? Clearly observe it. The total mass of disk is m. You are removing mass here, right or wrong?
Yes.
In my process, whatever process I did there, I'm not removing mass. I'm rearranging the mass. So mass plays a very important role. If you understand that, then only you can deal. Otherwise, whatever explanation I gave will lead to misleading answers. There is a negative effect of my explanation also. You don't know when to take mr square by 8 and mr square by 2. Confusion. See, the clear difference will be mass removal. Are you dividing into 4 parts and removing 3? Or dividing 4 parts, remaining 3 are placed on the first part without changing R. That's the difference. Next part is that instead of doing this, if I divide into, again, 2 more parts and this part I move it here, same R, right or wrong? Okay. Sir, I'll divide once again, then I'll remove the. So if I do all these things, I'll get a rod. So according to my logic, moment of inertia of this rod is mr square by 2. But you know very well, moment of inertia of a rod about an axis, which is at the end of this one, will be mr square by 3. Sir, why we got difference? Anyone is there who can tell me why I got difference? My question is, I took the disk into 4 equal parts and I overlapped one another. Then moment of inertia remains same. I'm going to slice entire 1/4 of a circle into 2 halves and I place it here. And again slice it and place it, slice it and place it like that. If you keep on doing it, you will get a rod. Moment of inertia of rod, in this method, we are getting mr square by 2, but we know moment of inertia of rod is mr square by 3. Why the difference?
Sir, because at one end there is no mass.
You're right. Answer is, which end mass is not there? Tell me. End A or end B?
At end A, sir.
Very good. Kind of. Yes. So if you observe carefully, the rod that we achieved by cutting it into pieces and overlapping, at this point, hardly there is a mass. And at this point, we have heavy mass that is non-uniformly distributed. Super idea. Perfect logic. I repeat. So if I slice it like this, if I keep on slicing it into pieces and overlapping them, so in this region, mass will be more. Technically speaking, entire mass on the periphery comes to a single point, right or wrong? Because we are crushing and keeping it there, right? And next layer like that, it will be. So mass is not uniform for this rod. The rod which is made by overlapping a disk, moment of inertia ml square by 3 is for uniform rod. Okay, that's the difference. So you have to be really careful here. Same idea can be used to calculate moment of inertia of a cone. I'm not speaking about solid cone, hollow cone. Go to the table, see that. Okay. Idea is like this. First, I'm going to take a disk. Moment of inertia is what? Tell me? mr square. Now, feel this. I will slice it a thin ring, outermost ring. I'll slice. Okay. The entire inner disk is there, na? I lift up by a very small distance, a millimeter you take. Next, whatever is there, and I lift it up a little bit. Then I'll take the remaining disk also. I repeat the process. What I did is that I took the disk, I took the outermost ring, I cut it out, and kept the ring there, entire disc lifted up. And again, I'm going to cut the outer ring. I'm going to lift the disc up. And again, I'm going to cut outer ring. And I'm going to lift the disc up like this. If I keep on doing it, you get a cone like this, right? Now, in the entire process, I'm not changing perpendicular distance. Check it. So moment of inertia of a disk is mr square. Hollow cone also mr square. Go and check the table. Now go ahead with question number 25. Answer for 25 is mr square by 2 only. We have 1/4 of a disk whose mass is m. How can you get 1/4 of a disk with mass m? You take a complete disk of mass m, divide into 4 pieces. If you remove 3 pieces, what happens? Tell me, mass becomes m by 4. No. Mass is m only, na? Means what? They divide into 4 parts and remaining 3 parts, they place it on this, right? Do you understand? So, mr square by 2. Answer IITJ question is. Okay. Question number 26. What is the answer? Question number 26, I already discussed. Moment of inertia I3, I4 are same. I2, I1 are same. That's already discussed. If they are same, you can write like this. I1 plus I2 is equal to IZ. This is by perpendicular axis theorem. I1, I2 same. Combining that, you can say IZ is equal to 2I1. Same way, we can say like this. I4, I3 same by sense, symmetry. And I can write I4 plus I3 is equal to IZ by perpendicular axis theorem. So if I substitute I4 equal to I3, then IZ is equal to 2I3. Now we know that I4 equal to I3 because of sense or symmetry. I2 is equal to I1 because of same sense and symmetry, because these two are passing through diagonals, perfect. And just now we got, by using the theorem, I1 equal to what? Tell me. I3. Means what? Moment of inertia about any axis, it is same. First and foremost thing, it is same. The question, you check it. The question, moment of inertia of a square plate ABCD of uniform thickness about an axis passing through the center perpendicular plane of the disk is, that is IZ. IZ can be written as what? Tell me. 2I1 you can write. I1 plus I2 you can write. I3 plus I4 you can write. So A, B are obvious. And observe, if you join them, it will be 2IZ is equal to 2I1 plus I3. 2 gets cancelled. I can write like this. IZ is equal to I1 plus I3 also. So answer is A, B, C. In fact, moment of inertia of the square plate in about any axis passing through its center in the plane, making an angle theta. Any angle theta doesn't matter. Any angle theta doesn't matter. It will be same. And that will be equal to half of the moment of inertia about this axis. Clear? So there are a lot of questions you have to complete. Try to complete all those things. And I'll give you one more concept here to find moment of inertia. If you can construct an object by repeating itself, then you can find moment of inertia by using a small technique. I'll explain. Suppose if you take a rectangle, by repeating rectangle, you can get another rectangle, right? Most important point is that when you're repeating, they must be identical. You can't repeat a rectangle, square like that. No, they must be identical. But remember this, by repeating 4 or 5 or any number of discs, you will not get a disc. So it is not applicable for disc, but it is applicable for rectangle or whatever object you are taking. You must be in a position to decide, yes, can I reconstruct entire object by using repetition of itself or repetition of itself in a smaller size? That small 4 rectangles will give you one big rectangle. In this case, you can use. What I'll do is that I'll use it. Let us take rod and let us consider moment of inertia of this rod is, you know very well, answer, ml square by 12, right? That's fine. But let us continue. Moment of inertia of rod I is equal to some unknown value alpha multiplied with mass and some dimension you take. Some dimension you take it. I'll take this distance as what? X. I'll take this distance as X. It is L by 2, we know. Let us take the distance as X. Okay. Mx square. Sir, I'm not able to understand. take the object, take moment of inertia of that object is some factor alpha, some numerical factor, 1 by 5, 1 by 10, some random number, one factor alpha. Mass of the body, obviously mass of the body will be there. And one dimension, that means I'm taking dimension as center to the end. The distance is x square. So that's the moment of inertia of a rod. Okay, clear. Now what I'm going to do is that I'm going to take this rod as combination of two pieces. One piece like this, two pieces, right? So let us consider moment of inertia is this one is I naught. So I naught is this one. Okay, now concentrate here. What is the moment of inertia of one piece? You focus only on this piece. Mass is m by 2. This distance is what? Tell me. X by 2. Yes or no? Moment of inertia about this axis will be, let us call this as I1 is equal to alpha m by 2 x by 2 whole square, x square by 4. That's the moment of inertia of this half rod. If I take axis about the end, moment of inertia will be, simply use what? Parallel axis theorem. So now I consider moment of inertia of this itself is I1, okay? I have to add that plus md square, m by 2. What is d? D is x by 2, right? X by 2 whole square. X square by 4, right? Moment of inertia of this half rod will be alpha plus 1 mx square by 8. Now, what about moment of inertia of the other piece? That's also same. If I take moment of inertia of left part is I1, right part is I1, about this axis, if I add I1 and I1, what I'm going to get? I naught, na? So, I naught is equal to I1 plus I1. Simply put this data here, this data here. You will get the answer. So, it will be alpha m x square must be equal to I1 plus I1 is 2I1. 2 into what is I1? Alpha plus 1 into m x square by 8. Now 8, how many times? 4 times it is. And mx square gets cancelled. So it will be 4 alpha is equal to alpha plus 1. Alpha is equal to 1 by 3. Now put this value here. You can find moment of inertia of a rod. So moment of inertia of a rod about an axis passing through its center will be 1 by 3 m. What is x? L by 2. Let us put L by 2 finally. L by 2 square will be L by 4, L square by 4. So moment of inertia will be ml square by